I'm Sean Harper. My job at Amgen is to see what's coming next in science. That's challenging because scientific progress isn't linear. It's more of a parabolic curve. On the flatter part of the curve, the change is gradual, incremental. But as you reach the steep part of the curve, the pace of change accelerates incredibly rapidly. Here is where we are in biology, the start of the biocentury. The progress we're starting to see in biology now is just as dramatic as the progress in physics and engineering that transformed life in the 20th century. My grandfather was born in 1900 and he didn't see an automobile until he was 13. By 1925, he was designing airplanes. By 1950, he was chief of structural engineering at Douglas Aircraft Company. He led the design team for some of the world's first passenger planes, and he oversaw the design of the Thor rocket, part of our response to Sputnik. As a kid, I asked my grandfather how he got such an amazing job, and here's what he told me. If you want to change the world, you need to work in a field where the science is exploding. For him, that explosion was in physics and engineering. Today, the most explosive changes are taking place in the life sciences. In the next 50 years, many diseases with few effective treatments will either be cured or controlled by medicines based on insight from human genetics and our ability to leverage that knowledge to solve some of the toughest problems we face as a species. I know that seems hard to imagine, but we're doing things in biology now that were unimaginable just 5 or 10 years ago. So if we're doing so well, why is disease still so common? In many ways, biology poses a tougher challenge than engineering-based disciplines. Biological systems and processes are incredibly complex, dynamic, and microscopic. In engineering, you can use computer modeling to solve very intricate problems. Put enough computers together, and almost anything is calculable. That's harder to do in biology since the systems themselves are analog, not digital. The one crucial exception is DNA, which is digital information that provides the code for making every protein and cell in the body. Our challenge has been that the human genome is massive. In book form, the DNA letters that make up your genome would fill more than 1 million pages. However, with today's computers, we can crunch genetic data and apply it to the challenge of figuring out how biology works and why disease happens. Fortunately, the fastest progress we've seen in any technology is occurring right now in the field of DNA sequencing. Moore's law says that computers double in speed about every 2 years, which is true for things like the laptop you use at home. Our ability to read DNA is improving roughly 1,000 times faster than Moore's law. In 2004, it cost $20 million to fully sequence a human genome. Today, we can do it for about the price of an iPhone. Even though we are just beginning to identify all the genes that can cause or prevent disease, we already have new medicines that are based entirely on recent genetic discoveries. And now that we have the tools to discover every gene that impacts human disease, our ability to design effective treatments will accelerate dramatically. Right now, we aren't just reading the human genome, we can actually edit the genes of living organisms. The robots we use to screen for drugs are faster and more productive. So are the computers and software that help us to visualize and design drug molecules. Biology is poised to change the world in the same way the internet changed the world. Perhaps even more so, because good health is the most fundamental need we have. Despite all the progress we've made with other technologies, we still accept the fact that any one of us could drop dead from a heart attack. We accept that 1 in 5 of us will eventually succumb to cancer. Few companies are mentally and technically prepared for all of these changes. At Amgen, we're more than ready. Our company was built by people who saw the incredible promise of biotechnology, and the people who work here today understand the historic opportunity that's in front of us. We're excited to be in the right place at the right time with the right talent and technologies to not only work in the biocentury, but to lead it.